All right, this is a continuation of section 6.3, and what we're dealing with there are vectors. We are going to first look at how we can use vectors to two vectors and then be able to find the angle between them. There is a formula that we are able to use, but at this point in time we're going to use the law of cosines to find it. So here's what we need to do. Let's go ahead and get ourselves an x and y coordinate plane, and we're going to plot these two vectors. I've got the vector 3i plus j, so that is 3, 1. So what we have is for component form for vector v, our component form would be 3, 1. And then I've got the vector 2, negative 1. And so vector w's component form is 2, 1, negative 1. All right, what we need to do is we need to find the angle between them. So actually what I'm going to do to find this angle, and I'm going to go ahead and create a triangle. So I'm going to get a third vector here, a third vector that is between those. And what I'm going to do is call that, if I make a vector between these two here, let's say I go from vector w to the end of vector v, so this is vector v, this is vector w, this would be v minus w. So vector v minus vector w. Now we're able to find that vector in component form by just using our operations and subtracting. So v minus w would be 3 minus 2, that's 1, and 1 minus negative 1, which is 2. So I found that that's our third vector. Now, in order for us to find the angle between here, what I'm going to use is the law of cosines. Well, to use the law of cosines, we would need to know the length of each of these three segments. So we're going to find the magnitude, and now what the magnitude is going to tell us is the length of each segment. So the magnitude of v would be the square root of 9 plus 1, so the square root of 10, and the magnitude of w would equal the square root of 4 plus 1, which is the square root of 5, and the magnitude of v minus w would equal the square root of 1 plus 4, which is also the square root of 5. All right, now in order to find the angle between, I start with its opposite side. So my formula is going to start with this opposite side right here, this vector, which is the square root of 5 squared equals the square root of 10 squared plus the square root of 5 squared minus 2 times the square root of 10 times the square root of 5 times cosine of my angle. This is what we're going to solve. So we've got 5 equals 10 plus 5, which would be 15, minus 2 times the square root of 50, and times the cosine of my angle. So we've got negative 10 equals negative 2 square roots of 50. If you wanted to simplify that, you can, times cosine of my angle. I'm going to go ahead and divide. So here's what we're looking at. Cosine of my angle equals, if you take negative 10 and divide it by negative 2 roots of 50, we're going to have 5 over the root of 50. I'm just going to go ahead and use that now. So you do inverse cosine of 5 over the root of 50. Now what that's going to give us again is your angle. You should be in degree mode, and the angle that you're going to get is 45 degrees. Now that is it. That's the angle between those two vectors v and w. All right, let's go ahead and jump over to example 13. In example 13, we are to find the component form of a vector that represents a velocity of an airplane descending at a speed of 100 miles per hour at an angle of 30 degrees below the horizontal. All right, we've got our x and y axis. We've got our airplane descending 30 degrees below the axis, so this angle is negative 30. And we've got our velocity of it is 100 miles per hour. So we're trying to find vector v, let's just call it vector v in component form. What we know is that the magnitude of vector v is 100. And we know the direction, so my vector in directional form then would be you take the magnitude 100 and you multiply it by the vector in direction form, which would be cosine of negative 30i plus sine of negative 30j. Get rid of this right here. All right, so there's our vector. You take the magnitude of it times, because this would be a unit vector, so magnitude times the vector itself. And what we need to do is go ahead and calculate what is the cosine of negative 30. So we've got our vector, 100 miles per hour. This is the direction of the vector, and cosine of negative 30 is 1/2 I plus, and sine of negative 30, our cosine is not 1/2, it's square root of 3 over 2. And then sine, since we're in quadrant 4, is negative 1/2 j. All right, let's go ahead and put the right form in place. We have the vector equals 100 times the component form of the square root of 3 over 2, comma 1/2. It's negative 1/2. And finally, this would equal, if you multiply by 100, 50 square roots of 3, and we're wanting to put this in component form, and then negative 50. There we have it, final answer. All right, we've got one example left here for this video, and it's an example 14, and it's asking us, or telling us, that if an airplane is traveling at 500 miles per hour with a bearing of 330 at a fixed altitude, with a slight wind velocity of 70 miles per hour in the direction of northeast 45 degrees, what are the resultant speed and direction of the airplane? All right, so we basically have got two vectors here. We're going to have the vector of the airplane, and it's 500 miles per hour at a bearing of 330. And we're going to have a vector with the wind direction, the wind and the direction. So the resultant vector is we're going to add these two vectors together. So the first thing that we're going to do is let's go ahead and list the vectors. So let's call vector A is going to be the airplane. So the airplane's vector, we have a velocity of 500 miles per hour, so it's 500 times, I'm going to go ahead and use the direction. If I've got the airplane at 330, let's look at where 330 is located. So I've got 330 would be all the way around to this angle, but I'm going clockwise all the way around to 330. Okay, what that means is the angle from here to here is 120. If all the way around is 330, then I know that there's a difference of 30 degrees here to the left of the y-axis, so that's 120 degrees is what we're looking at. So the directional vector would be cosine of 120i plus sine of 120j. Okay, there's your airplane vector. Now your wind vector, I'm going to call it W, would equal 70 for the velocity And at 45 degrees would be cosine of 45, I, plus sine of 45, J. Okay, so what I need to do is go ahead and find these vectors in component form, and then we will add them together. So vector A in component form. So we've got 500 times cosine, the cosine of 120, which would be the x value, it's negative 1/2. And the sine of 120 would be the root 3 over 2. So this equals 250, negative 250, and comma 250 square root of 3. Okay, my wind vector would equal 70 miles per hour times the cosine of 45 degrees. So here's the wind vector. I guess we didn't draw that in there. Here's my wind vector. Now with it only being 70 though, and 70 is about 1/7 of 500, so that vector is definitely a lot smaller. All right, so what we've got is the cosine of 45 is the square root of 2 over 2. We're in quadrant 1, and sine is the square root of 2 over 2. So the result is, in component form, 35 roots of 2, comma, 35 roots of 2. All right, so here's what we've got. Our goal was to take vector A and add vector W to it. Let's look at see where that would be located. Vector A plus vector W. All right, you can draw the parallelogram, or you can attach vector A on here. And so where we're at is right there. This is the resultant vector. We're in quadrant 2, and you'll see that here. All right, let's go ahead and add these vectors together. So our final result here, just for the actual vector itself, we still have to find the speed and direction of the airplane. So the vector is going to be, you have to add these two vectors together. So it's negative 250 plus 35 roots of 2, comma, 250 roots of 3 plus 35 roots of 2. Now, for the purpose here of, the fact that these two vectors are a pretty big expression, I'm going to go ahead and find the decimal equivalents to them. And they would be negative 200.5, comma, 482.51. So there's our vector, okay? Our vector is in quadrant 2, and we need to find the speed, and then we're going to find the direction of the airplane. All right, so here again is what we've got. We've got our vector A plus W. This is the airplane with the wind along with it. We're in quadrant 2, and let's go ahead and find the magnitude. So we're going to take the square root of negative 200.5 squared plus 482.51 squared. And this is going to give us a magnitude of 522.51 miles per hour. Okay, so there's one of the two answers to our question. Now the second thing that we have here is we've got to find the angle, okay, the direction. And our angle that we're going to find has to be a radial measure, and it's going to go from the north all the way around to my resultant vector. So really, in order for us to even start anywhere, we need to find the angle. And the angle is found by taking the inverse tangent of my x and y coordinates here, the y value, 482.51, divided by the x, which is negative 200.5, If you take the inverse tangent of that, what we're going to find is we're going to find the angle. Okay, so we're going to go ahead and find this inverse angle, which this actually gives us negative 67.4. Well, negative 67.4 is this angle. Right down here. Since tangent is negative, it actually gave us the angle in quadrant 4, negative 67.4. Well, if I subtract pi from this, if I subtract pi, then what I'm going to find is I'm going to find the angle that goes all the way, I'm going to find the green angle is what I'm going to find. So let's subtract pi from this. Not subtract pi, we have to add 180. We're not in radians, I don't know what I was thinking. We have to add 180 degrees, and what that's going to do is it's going to bring me back to the green. So since this is a straight angle, the green here part to the top, my resultant vector, and then the angle that I actually found, if I come back and I add pi to it, I'm going to actually get the angle here at my resultant vector. And so this is 112.57 degrees. All right, what I really need though is I need to know what this angle here is in the middle. I need to know what this angle is right in here. What is the angle? So if I know that the whole thing is 112.57, if I subtract this right angle of 90, then that's going to give me the inside angle. If I subtract 90 from that, and that gives me 22.57. Okay, so again, in the very beginning, what I told you was we needed to know the angle all the way around going up to that vector. What I know is I know the inside angle is 22.57. So final result, if I take the 360 all the way around minus the 22.57, this is going to give me my resultant angle, which is 337 degrees, 0.43. So final angle. That is a radial measure. We also have an angle of 22.57, and this is a northwest angle. There's another option for you. All right, that concludes then this section here, and your assignment is page 418, and it's 73, 74B, 81, 82, 95 through 108, all.